Here's the question. Move this over. So Vasquez hopes to retire when he's 65. So starting from his 35th birthday, he invests $2,500 compounded quarterly with a plan that offers 4.5% interest per annum compounded quarterly for 25 years. So he invests $25,000. That's the R. It's compounded quarterly. So that'll play a factor in the I, which is 4.5. And this goes on for 25 years. So then, that's part 1. We color code this, part 1. Part 2, he then takes this money and invests at a rate of $5,600. So we want to take the money he earned from this investment and put it into a compounding account for 5 years. So that's part 2. And finally, we want to see how much money he'll be able to withdraw. So we want to find the R value if he wished to keep receiving money until his 75th birthday. So we need to find the present value and find the R value based on that. It's as simple as that. Alright, so let's work through this question. We'll do part 1 first. So this is an annuity question. So the amount is equal to R, $25,000. I'll just write the formula first. Into 1 plus I power of n minus 1 over I. This is equal to $2,500 into 1 plus 0.4045 divided by, because it's quarterly, it's divided by 4 to the power of n, which is 25 times 4, which is 100, minus 1 all over I, which is basically, I is basically 0.045 divided by 4. So when you plug this in 25 years, he'll have saved $457,984.54. And so that'll be his value for the second part, which is his compounding period. So part 2, he invests this money back into the account at 5.6% per annum for 5 years, which is compounded monthly. So we're going to have to use the compound formula, which is equal to A equals P into 1 plus I power of n. So this is equal to 457,984.54 into 1 plus the interest rate, which is now 5.6, and this is over 12 because it's monthly, and he does this for 5 years with 12 months. And so after the 5 years of this money being compounded, he will have, this is actually 0.056 when you convert it to decimal. And this is ultimately equal to 605,578.46. So this is the money he'll have when he's 65 years old. But we're not done there. We want to see how much money he can withdraw so the money lasts until he's 75, which is part 3. So this one, he wants to make regular withdrawals. So this, the value we found from this becomes his present value. This is his, this is his interest rate, and it's semi-annually every 6 months. And so we want to find R, or the present value, for 10 years, 75th birthday. So let's plug in the values for the equation. P.V, part 3, is equal to the money into 1 minus 1 plus I, the power of negative n, all over I. And so once you sub in the values, this is your present value. So 605,578.46 is equal to R into 1 minus 1 plus the interest rate, which is 6.2%, 0.062 divided. We want to divide this by 2 because it's semi-annual. The power of negative 10. Multiply this by 2. Semi-annual. All over 0.062 divided by 2. And when you isolate for R, we see that it equals, so every 6 months he will be able to withdraw $41,081.65. And so therefore, if he wants to maintain his money till the age of 75, he can withdraw $41,301.65. And so if you can do this type of question, you've pretty much mastered compound interest annuities, and that's all.